All right, B-Tech students, listen up. So most of the programming you've done so far, it's probably felt like writing a recipe for a computer, right? Super precise, step-by-step instructions. But what if, instead of writing the recipe, you could just describe the scene of a crime and have the computer play detective? Let's dive in.
Yeah, so that style of programming you're used to, with languages like C or Java, that's called imperative. It's built for computers that just follow one instruction after another. You're the boss, giving every single command. But logic programming, it completely flips the script. Instead of giving orders, you're basically providing knowledge. You just state the facts, lay down the rules, and the language itself, well, it figures out how to connect all the dots. And this, right here, is where our story really gets interesting. Because when a problem is less about crunching numbers and more about, well, deduction and relationships, you don't need someone who just follows a recipe. You need a detective.
So let's go ahead and meet our detective. And that detective is the logic programming paradigm. And trust me, this is a completely different way of thinking about code.
Okay, so what is it exactly? At its core, logic programming is a paradigm that's built on, well, formal logic. Your program isn't just a list of commands anymore. Nope. It's more like a knowledge base, a collection of truths and rules about whatever problem you're trying to solve. And the most famous language in this whole family, the one we'll be using as our main detective today, is called Prolog. And this quote, it really highlights that fundamental shift in mindset. See, you're not telling the computer, hey, do this, then do that. Instead, you're asking it a question. You're saying, hey, based on everything I've told you, can you prove that this statement is true? It's a subtle difference, but it's incredibly powerful. It's the difference between calculating an answer and discovering it. You know, any good detective needs their toolkit to crack a case, right? Well, our logic detective is absolutely no different. It works with 3 essential tools to solve pretty much any mystery you can throw at it. Okay, first up in the toolkit, facts. And you can think of these as the rock-solid, absolutely undeniable clues, the stuff we know for sure. For instance, Father John Pete. That's not a command, it's just a statement. It's a fact. John is the father of Pete, full stop. These are the building blocks, the foundation of our entire case. All right, tool number 2, the rules. This is like the detective's rule book, the guide to how everything connects. Basically, rules are how we define relationships between the facts. So take this example for grandfather. The rule says, for some X to be the grandfather of Y, there has to be some other person, let's call them Z, where X is the father of Z and Z is the father of Y. See how that connects the dots? This is what gives our detective its power of inference. And that brings us to the third and final tool, the query. This is it. This is the big question you're actually trying to answer. So using our example, we could ask the system, grandfather, John, who? Now notice, we're not just asking a yes or no question like, is John a grandfather? We're asking the system to find the person, that variable who, that makes the statement true. Okay, so we've got our facts, we've got our rules, and we've got our query. Now let's pull back the curtain and see how the detective's brain actually works. How does it solve the mystery?
So the magic happening behind the scenes, the core process, is something called unification. Honestly, the best way to think about it is as a really powerful, really sophisticated kind of pattern matching. The system takes your question and just tries to find a way to make it true by matching it against all the facts and rules it knows.
Let's actually walk through this. Step 1, we ask our question, our query. Grandfather John, who? Okay, so the system immediately starts looking for a match. Boom, it finds our grandfather rule. It then does that unification thing. It matches our query to the rule. So the variable X in the rule gets locked into our known value, John. And now the system has a new set of goals. It has to satisfy the conditions of that rule. First, it needs to find a Z so that Father John Z is true. It scans the facts, finds Father John Pete. Perfect. Z is now Pete. Then it moves to the next condition, Father Pete, who. It scans the facts again, finds Father Pete Mike, and it binds who to Mike. Case closed. The system found the answer, Mike.
Okay, so right now, this might just seem like a really neat trick for solving family tree puzzles, right? But the truth is, our logic detective has been the lead investigator on some seriously important cases in the world of computer science.
Logic programming has been a huge cornerstone of artificial intelligence, particularly for building what we call expert systems. Just imagine a medical diagnosis program. You feed it a bunch of symptoms as facts and a ton of medical knowledge as rules. Then you ask it a query and it deduces a possible illness. That's logic programming at work. And it doesn't stop there. It's fundamental to how relational databases work, and even natural language processing, anywhere that understanding the relationship between pieces of information is the whole ballgame.
So, all these different fields, they've all got one major thing in common. They are not about just crunching numbers. They're all about understanding complex relationships, finding patterns, and making logical deductions. This is exactly the kind of work our detective was made for. So, let's recap. We've met the detective, we've looked inside their toolkit, and we've even watched them solve a case. So what's the crucial takeaway? What's the one thing you really need to remember from all this? For you, as a B.Tech student, this is probably the most important part. Learning a language like Prolog isn't just about memorizing some new syntax. It's about completely retraining your brain to look at problems from a whole new angle, from that declarative, here's what's true perspective, instead of the imperative, here's how you do it, way you're used to. And with that, we're at the end of our case file, but I want to leave you with one final thought. I want you to think about the projects you're working on right now, the complex systems you're studying for your classes. Where could you use a little less step-by-step instruction and a lot more deduction? What mysteries are out there, in your world, just waiting for a logic detective to come in and crack the case?